types of arrays. That is a traditional array, homogeneous array, and we have a diagonal array, and we have a numerical array, and we have a random array. So those arrays we were discussing in the last session, and we discussed how we can generate those arrays, so traditional array and homogeneous array and diagonal array and diagonal array also we have seen. Today, let us continue with the diagonal array and numerical array and random array. Those arrays, we see how we can generate those arrays. Okay, in using a NumPy. In a NumPy, we are using those arrays concept to generate the generate arrays. Okay, so diagonal array. One second, I'll stop sharing screen for 1 minute. Okay. So yes, let us import NumPy NumPy as np. Okay, import NumPy as np. Mhm. Okay, and here using np, what we'll do, we will with np, we will do, we want to generate a diagonal array. So for that, what we'll do, we use I, and in I, what we'll do, we can use, let's say, 3 dimension, yeah, 1 dimension only, but we can check the dimension. We can check the dimension. Let me put it into the array. AR1 is equal to engineering, and AR1 dot ending, engineering, AR1 dot ending is a 2 dimensional array. Okay, and here let's do one more thing. np dot dey 3 comma 3 comma let's see 3 3 comma 3. It is giving the end time, and it is giving the 2 dimensional array. But here, what I want to do is I want this diagonal not in the in this uh, in or in the first column or first row. I want to make it in the second one. Okay, let me show you. Let me show you. So here, so for that, what we can do is we can so here np dot eye let's say 4 comma k minus 1. equal to, okay. So what it is doing, it is not making the diagonal at the mid of the matrix. It is doing one level below, one level below it is doing. Here I am giving k minus 1. So from diagonal, for the mid of the diagonal to one level below. But I want to make minus 1 I have given. Let us give plus 1. I mean, let us give 1. We'll see what it is. np dot eye here, let's say we'll give 5, comma, k is equal to 1. K is equal to 1. So let me see. It is giving above 1 line. The diagonal, it is giving above 1. If you same way, if you give k is equal to 2 means it will come to the above 2 lines. From the diagonal above 2 lines it will generate a matrix. Let us see that one as well. Let us make k is equal to 2. np dot ey 6, comma, k is equal to 2. Okay. So let me run. See, see, see. This this is the mid of the diagonal, but it is going 2 steps above and it is giving you the diagonal. So like this, what uh, we can generate the we can generate the uh, diagonal element by using the NumPy. When we are processing the data, these kind of things will this kind of diagonal things it is required. Okay, so that you'll see when it will come to know. Now let us see about the numerical array. Numerical array. Till now we have seen the diagonal array. We have seen the traditional array, and we have seen homogeneous array, and we have seen diagonal array. Now let us see about the numerical array. Numerical array. Numerical array. So numerical array is nothing but it's kind of a range. It is like a range. Numerical array. Numerical array is a kind of range. Range function. In Python, the range function. It's kind of a range function, but there is other advantages for that range function. We will call this one as a range. A range. A range in NumPy. A range in NumPy. A range in NumPy. So let us see how we can implement that. Let's see how we can implement that. So here np np dot a range np dot a range. So here let us generate the range 1 to 10. First let us generate 1 to 10. So it is generating 1 to 10. But here I want to give a step of 1 means 1 means 3, 3 means 5. Means it will jump to one step. Means step of 1, 1 to 2, 2 to 3. So if I give step of 2, give step of 2, so it is 1 to 3. There is no 2 here because it's step 2 steps, it's step. And 3 to 5. There is no 4. 5 to 7. 7 to 9. So it's step 1, 2 steps, it's step and it is giving the numbers. Okay. So this is in array. In a numerical array, we have this option. Numerical array, we have this option. Okay. So let me np dot array. No, let's say 1 comma to 1 to 25 with step of 2. Step. Okay. And this will be always the range, the numerical array. It will be always the one dimension. Let's give variable array array one, or let's give the name as array n. N is numerical. Why I'm giving that one is to check the dimension. Array underscore n dot nd. This is one dimension. So numerical array always it will be a one dimensional array. Now let us go for linspace. Linspace is also part of the numerical array. Lin, linspace. So it will accept that here. It will do the it is give the 10 comma and it is taking it. It will give you the automatically uh, the number. It will automatically generate from 1 to 10 with with a gap of some 100 between the numbers. It will give some spaces there. Okay. With the gap of 100, but very minimal things it will do. Even the negative number, the float number, it will generate here. Here, here the range will give you only the integer number, but in this space it will give you the float also. Means negative kind of numbers also it will give you the link space. Okay. So this is one type of array. The numerical array, link space is one type of array. There is one more thing here in the link space. Np dot link space, link space 1 comma 10 comma 100 comma red step red step red step is equal to 2. See, returns evenly spaced numbers over a specified intervals. Okay, return number evenly spaced samples calculated over the intervals. The endpoint of the intervals can optionally be excluded. Okay, it will give you the spaced numbers. Internally, it will generate and it will give you the it will give you the random numbers kind of thing. Okay, so let me generate that. Mhm. From 1 to 100, it is generated. It is having the float as it will generate the float value. It will generate that. Then spaces. If the spaces will generate. That's the red step is a function which we use to generate the random number. Okay. So this is about the numerical array. Now let us discuss about the random array. Okay. Random array. Random array. So in random array, what we'll have is we'll have np dot random dot rand of the file. np dot random dot rand. Rand is a function which we use to generate a random value. So it will generate a random value. So for five numbers, I gave five, so it generated the random five number. So here, let me give here. It will give you the float. Float also. You give the. I just want to see the dimension. Dimension. Array dot d. End. Give you dimension to one dimension. Okay. The same way, we have rand n as well. Here we have given random dot rand. We can give random dot rand n. There is another thing. So rand n is also another kind of. Let me give np dot random dot rand n. Rand n. Okay, so rand n. So we need to give the range. Rand n, and here we will give 3 comma 5. So it will generate the random value. Hmm? Generate between 3 to 5, the values, whatever value is there, it is generated. And there is another thing, rand int. Rand int is also another option. There, let's say, here, between 3 to 5, you want to generate the number. So you don't have a limit. Let's say I give 3 to 5, but it generated the random number, multiple numbers generated. But what I want to do is I want to generate only five random values. So for that, what we can do, rand int, random, random, rand int, rand int, random. Okay. So let's see. Let me use the text only. random rand int random. Now let me code np dot random dot rand int is 20, comma 40, comma 5. This random value is defined. Okay. So what we can do, we can generate the number like this. Again, and we can use those random numbers. Okay. This is what about generating the arrays using NumPy. Like like we generated the traditional type of arrays. We have generated homogeneous type of arrays. We have generated diagonal arrays, and we have generated the numerical array, and we have generated the random array. There are multiple arrays that we can generate using the NumPy. So these are all NumPy related libraries that we use to generate the NumPy array. Okay, random array, random in space. So all these arrays we will use. Okay, yeah, we'll stop here. Wait. We'll meet tomorrow at same time, and I will discuss the rest of the NumPy related library. Okay? Thank you.
If you found this video helpful, don't forget to like, share, and subscribe to our channel. Thank you.